there's been a dangerous gap between the climate science and the warnings of climate scientists and the economic models we've been using to prioritize our action. And to close this gap, we really need to create room for some new ideas. And so today I'm going to be sharing some of the insights from climate risks and tipping points from the University of Exeter, and share along the way some examples of where these are being better integrated to support better decisions. So the last 3 years have been the warmest on record, and we've seen the 3-year average has been 1.4 degrees C, and with an upcoming El Nino, this is only going to continue to strengthen. And so we've seen really these extremes starting to get larger and more frequent, and that's having a lot of consequences. First, for countries like Pakistan, we've seen in 2022 a flood that cost 1/3 of public spending, really large. And we're seeing with the insurance market, some markets are starting to, or insurers starting to withdraw from markets because the extremes are getting too large to reasonably price. Now, we are entering into this new reality, and that is one where we're putting a lot of pressure on the safe operating space of the Earth. So this is the planetary boundaries framework. It's got 9 indicators of elements that are life-sustaining for us here on Earth and that are under pressure, and 7 of them are said to be crossed, and a number really in the red zone. And we're really drawing from our life-supporting capacity with regards to biodiversity. Geochemical flows are really at all-time high, and climate change is just one of a number of key issues. I'm going to be focusing largely on climate today, but it is really important to keep those in mind. Now, these climate risks are getting worse because of tipping dynamics as well. And so these are where Earth systems are changing, and these can amplify global warming. And what these tipping dynamics had been thought of as really high impact but low probability events previously, but this assessment is constantly evolving, and that's where Exeter's work has accelerated this agenda. Now, to get you into the mode with a small analogy, I'd like you to think of sitting in a chair, back in school, wooden chair. You're in a stable system with 4 feet on the floor. But if you to kick back onto 2 legs now with a large anthropogenic force, that will give you put you into an unstable state. And you can imagine that feeling. You've probably experienced it before, where you realize you've gone too far, and the forces of gravity have you going backwards, and you end up into a new stable state with the back of the chair on the floor. Now, this silly example illustrates a tipping point in action. It's got 2 of the 3 elements that we look for when we're describing it. First is self-reinforcing feedbacks that amplify change. And second was threshold behavior, where small changes to parameters can trigger really large changes, like an example with the ball. The third, which is persistence, which makes transitions difficult to reverse, isn't so relevant for our chair, but is really important for the climate. Now, when we think about these tipping points, we can take a helicopter view. Here is a map from the Global Tipping Points Report 2025, and it shows the elements that are closest to tipping across the biosphere, cryosphere, and circulations. And this is due to global warming. So the first is coral reefs, which have been shown to be across their thermal tipping point, and that's going to disrupt the livelihoods of hundreds of millions of people who depend upon those reefs. B and C, these are our polar ice sheets, and if these tipping points are crossed, we're committing ourselves to irreversible sea level rise of several meters, and again, this will be very disruptive to the livelihoods of hundreds of millions of people. Now, permafrost and D and the subpolar Gaia are also thought to be reasonably near. each fraction of a degree increases the likelihood of crossing a tipping point. And this diagram shows that really well. A key one here, which wasn't on the previous one, is the Amazon rainforest dieback. And the latest research is telling us that this could be triggered below 2 degrees. And again, this is providing livelihood to hundreds of millions of people, but also acts as a global climate regulation anchor. Now, the Atlantic meridional overturning circulation, this is described as the tipping point that cannot be crossed because its consequences would be so large. So what this is, see on the map diagram here, is a relatively warm ocean current that comes up through the Southern Ocean, through the Caribbean, and up into the high northern latitudes there. And as it's giving off a lot of heat to the atmosphere, it cools enough to sink down and start to come out south in the blue as colder water. And it's the combination of the AMOC and the Gulf Stream that provide a lot of heat transfer that make Western Europe a lot warmer than other countries in high latitudes. Now, the paleoclimate data is showing us that this has been a stable system for many centuries, but observational data and estimates have shown a 15% weakening since the pre-industrial era. And the consequences of that is what you can see is that blue blob in the center of the diagram there. And that's showing a cooling on the sea surface temperature, the only place in the globe where this is happening. Now, when we talk about collapse of the AMOC or shutdown, really it's a reduction in the flow below a certain threshold. It's not the complete turning off, but the terminology is important. Now, Dreifeld et al. Last year produced a paper to show the probabilities of transitioning to an extremely weak AMOC. And the findings were under high emissions scenarios, this is a 70% likelihood, reducing to 25% in a low emission scenario. And their finding was that this really no longer complies with that high impact but low likelihood description that had been previously relied upon in the IPCC reports, and that really needs an urgent update in AR7. More recently, Portman et al. Have reconstructed a estimate based on constraining a number of models in the ensemble of models that project this, and they've found that a 50% weakening is possible by the end of the century. Now, the consequences of an AMOC shutdown might not be felt in true spirit for 50 to 100 years, but this could be triggered within the next decades. And the consequences of food production would be quite catastrophic. A Ritchie et al. Study from the UK simulating AMOC shutdown, this showed that the UK could lose 80% of the land suitable for arable production. This sort of change is not limited just to the Western Europe, however, and this diagram here from Lenton et al. Showed that we could lose 50% of wheat and maize production globally if the AMOC was to shut down. The economics that we've been using to make our decisions haven't been keeping pace with the climate science here, and the assessments have been largely long-run estimates to GDP, extrapolated based on observational damages, like you can see in the diagram here, and heavily discounted, favouring current over future generations. William Nordhaus's DICE model is a really classic example of this. It's been very influential within the IPCC and governments, and it's fitted a quadratic equation over top of this historical data. And that has led to conclusions that 3 to 4 degrees of warming would be optimal. Professor Steve Keen has taken apart this work and has shown that it misrepresents some of the tipping points literature and leaves out a large portion of the economy. there are other ways in which to extrapolate based on that historical data, fitting other types of functions to it. And you can see with this approach, a quadratic at 3 degrees C produces a 4% hit to GDP, but other options, exponential in brown is 10%, logistic could be 60% plus, and Gompertz is nearly 90%, which is a complete loss of the functioning economy as we know it. Now, the Carbon Tracker and University of Exeter folks recommended not to pick one over the other, but really to recognise there is so much uncertainty about where these future damages could be and how disruptive they are, that we shouldn't be really optimising just around this one number based on a quadratic function. What you're seeing here is a summary from JP Morgan, and they've produced a recent publication about pricing in tipping point risk. And what you're looking at in this diagram is a example of how they're thinking about communicating this to different investors who have different investment time horizons. And you can see it's really relevant for a number of, or for most investors, even within the next 5 years. And they say ignoring this can lead to mispricing of assets before an investment, or deterioration of it over the lifetime of these assets. So this is really helpful stuff here. It's helping to make this like far more relevant and tangible for something that is like quite a probably a high level and scary concept for investors. It is worth noting here, JP Morgan, they are the largest investor in fossil fuels, and the report here does fail to mention fossil fuels, oil and gas, or coal. And so I guess a question for the audience, do you think it's dangerous to be advancing this point around pricing and tipping risk, but also simultaneously betting on climate chaos? An inability to anticipate nonlinear change has also been holding us back in the transition. And this is based on economic models which are focused on least cost optimization, often just relying upon the carbon pricing mechanism as a single tool for decarbonisation. And this misses really important positive reinforcing dynamics of cost reduction leading to further diffusion and creating a positive tipping point, one you might have seen with solar a lot. And these create these S-curve dynamics, which you can see in the diagram here. Taking this, we can apply it to different sectors of the economy, and colleagues have published a paper about a positive tipping point towards electric vehicles. Now, it's important to note positive here is requires a lot of value judgment, and there's obviously shortcomings of a full-scale transition to EVs that should be aware of, and we're making judgments about this. However, what you're looking at is this bar graph on the right is global EV sales, which you can see is starting to grow exponentially. And on the left-hand axis, we actually have battery costs plotted over time, which you can see are really dropping consistently. And that's that diffusion cost reduction dynamic at play here. So these colleagues have been able to stimulate the transition and these dynamics and figure out the point of cost parity and future, and model policies to bring that forward and really accelerate that transition. These dynamics are really repeatable. And interesting, going back to the ball diagram, we've got indicators of loss of resilience in that incumbent system. With the Iran war in particular and the cost of fuel, we've seen a really large increase in EV sales, in particular in the UK. It's gone to 53% of new vehicle sales in April. Previously, the one-year rolling average had been only 24%. So an indication that that system is becoming less resilient to the incumbent. So the question is, will we continue to be surprised by these dynamics in action, or will we plan for them and structure our economy in a way that brings these forward, the changes that we liked? So to conclude, I'd like to say that the approaches that we've been using with cost benefit analysis and our economic models have really been letting us down when it comes to climate change. And colleagues are advocating for an approach that focuses more on these heavy tails, both the risks and the opportunities, which can be really large. Now, this would allow us to operate far more realistically within the safe operating space. It will require us to embrace uncertainty a lot more, be prepared to work with a multitude of different futures and not always have the perfect number. That false certainty is a real dagger for us. So to do this, we need some new models. First would be updating our mental models for understanding risks and opportunities, the potential for these huge upsides and downsides. Second, it's the economic models that we use to prioritize things we value, one action over another. And lastly, we need a change in the things we value beyond GDP and a fresh approach to how we value it. And I think that's where the work of both Delphin and Richard really add a lot. So with that, I'll leave you there and pass on to Delphin. Thank you.